Okay, hi everyone. Hi everyone. Welcome back to this video series. Today I want to discuss our next part of Windows Server 2000, Chapter 6, Managing Group Policy, enforcing configuration and security across the enterprise. One of the most transformative tools introduced alongside Active Directory in Windows 2000 Server is Group Policy. It empowers administrators to centrally configure and enforce settings across users and computers in a domain. With Group Policy, organizations can maintain consistent security standards, deploy software, manage desktop environments, and streamline administrative tasks without manually configuring each workstation. This chapter will guide you through the core concepts, structures, tools, and best practices for using Group Policy in Windows 2000 Server environments. 6.1. What is Group Policy? Group Policy is a feature of Active Directory that enables administrators to define configurations for users and computers across an organization. These policies are stored in Group Policy objects, GPOs, and applied based on where they are linked in the Active Directory hierarchy at the site, domain, and organizational unit OU level. Policies can control hundreds of settings related to security, password policies, user rights, desktop environments, start menu, taskbar settings, software deployment, scripts, logon, system behavior, Windows update, control panel access. Each Group Policy object has two major parts. One, computer configuration, applied at system startup regardless of user login, contains Windows settings, security settings, software installation, scripts, startup, shutdown. Two, user configuration, applied at user login, contains Windows settings, scripts, log on, log off, folder redirection, administrative templates, control panel, start menu settings. Both components are organized in a tree structure and use administrative templates, ADM files to define registry-based policy settings. 6.3. How Group Policy is applied. Group Policy processing follows a defined order of precedence known as LSDOU. Level description, local policy on the individual machine, site policies linked to the AD site, domain policies linked to the domain OU, policies linked to organizational units. Order matters. The last applied policy in the hierarchy takes precedence. OU overrides domain, etc., unless overridden with no override or block inheritance options. 6.4. Group Policy Management Tools. While Windows 2000 lacks the later Group Policy Management Console GPMC, administrators still have robust tools available. Key tools: Group Policy Editor, gpedit.msc, used to edit local GPOs or GPOs attached to a domain OU, Active Directory users and computers. ADUC allows you to link GPOs to domains or OUs and manage security filtering. Resultant set of policy, RSOP. Basic simulation can be performed with command line tools or manually reviewing settings. 6.5. Creating and linking GPOs. To create and apply a GPO, open Active Directory users and computers. Right-click on the domain or OU, select Properties, go to the Group Policy tab, create a new GPO, click Edit and configure settings using Group Policy Editor. You can link existing GPOs to multiple OUs or domains and prioritize their order. 6.6. Group Policy Settings. Here are some frequently configured policy settings in Windows 2000. Security settings, password complexity and length, account lockout policies, user user rights assignment, audit policy, log on events, object access, user interface, disable control panel, remove run or search options, set desktop wallpaper, redirect folders, my documents to a server share, software management, deploy MSI packages to users or computers, assign versus publish applications, automatically uninstall applications when out of scope, scripts, log on, log off, or startup, shut down batch files, automate drive mapping, printer setup, or maintenance tasks. 6.7 Advanced Group Policy Features, security filtering. By default, all authenticated users receive GPOs linked to their OU or domain. However, you can use access control lists, ACLs, and GPOs to target only specific users or groups. WMI filtering, not in Windows 2000. Note, WMI filters were introduced in Windows Server 2003, not available in Windows 2000. Loopback processing, used in kiosk or shared workstation environments, allows user policies to be applied based on the computer they log into, not just the user's account. Modes, merge combines user and computers GPOs, replace, ignores user GPOs and user computers GPOs. 6.8 Troubleshooting group policy. Group policy can fail due to network issues, replication problems, or DNS misconfiguration. Use the following tools and methods to troubleshoot. Tool purpose. GP result shows effective policies for a user computer. Event viewer, check for group policy processing errors. DC diag, check health of domain controllers. DNS console, ensure correct SRV records exist. Common issues, missing or incorrect DNS records, GPO not linked properly, ACL prevents user from applying GPO, replication delay between domain controllers. 6.9 Best practices for group policy, use of OUs to logically group users and computers for policy application, minimize the number of GPOs linked to each OU to reduce login times. Document, allow GPO changes and purpose, avoid setting the same policy in multiple GPOs, conflicts cause confusion, use starter GPOs or templates for common settings in later Windows versions, GPOs in a lab environment before deployment. Real world examples. Example 1, enforcing a secure workstation policy. Secure workstation policy, set password length to 10 characters, disable USB storage via registry policy, remove control panel access, set logon banner with company policy, linked OU workstations. Example 2, deploying Microsoft Office. Assign Office 2000 MSI to computers, deploy script to configure licensing settings, enabled scheduled restart after installation, linked OU staff computers. Summary. Group policy in Windows 2000 Server gave administrators unprecedented control over system configuration, security enforcement, and software deployment through careful planning and structure. Group policy can dramatically reduce administrative overhead while enhancing consistency and compliance across the organization. In the next chapter, we'll dive into DNS and name resolution, the critical services underpinning AD functionality, domain controller directory, and network security. So what I want to show you here are two servers. There are two Dell PowerEdge 2500s. This is the tower version. This is the rack server version. So these servers came into production in 2001, and these servers were specifically built to run Windows Server 2000. So these servers would have ran on the Pentium 3 processor and would have had 256 megabytes of RAM. So the next server after these was the Dell PowerEdge 2600, which was designed to run Windows Server 2003. So chapter 7, DNS and name resolution in Windows 2000, powering directory services and network identity. Windows 2000 Server introduced a tight integration between Active Directory and Domain Name System (DNS), fundamentally changing the way name resolution operated within Windows-based networks. DNS became not just a support system for internet-based name resolution, but the backbone for domain controller discovery, service location, and authentication in Active Directory environments. In this chapter, we'll explore the critical role DNS plays in Windows 2000 Server, how it integrates with Active Directory, how to install and configure a DNS server, and how to troubleshoot common DNS issues. 7.1 The role of DNS in Windows 2000. Traditionally, Windows networks relied on NetBIOS and WINS for name resolution. With the advent of Active Directory, those protocols became legacy solutions. DNS took over as the primary name resolution service for locating domain controllers, resolving Active Directory service records (SRV), mapping host names to IP addresses, supporting Kerberos authentication, enabling replication between domain controllers. Windows 2000 DNS is designed to be RFC compliant, supporting standard features like forward and reverse lookup, dynamic updates, and delegation. 7.2 DNS versus WINS and NetBIOS. Feature DNS WINS NetBIOS protocol TCP IP port 53, NetBIOS over TCP IP NBT namespace, hierarchical FQDN flat, example name server1.contoso.com server1, update type dynamics or static, dynamic via WINS, Active Directory use, essential legacy support only, while Windows 2000 still supports WINS for backward compatibility. New AD environments should be built around DNS. 7.3 DNS and Active Directory integration. Active Directory relies heavily on DNS for service location through SRV records. These records enable clients to find domain controllers, global catalog servers, and Kerberos authentication services. So we'll just go through this here. Important SRV records, record type, purpose, LDAP, TCP.DC, MSDCS, domain.com, locate domain controllers, Kerberos, TCP.domain.com, locate Kerberos servers, GCTCP.domain.com, locating global catalog service, LDAP, TCP site name.sites, locates DCs by sites without properly functioning DNS, and these records, AD logons, group policies, and replication will fail. 7.4 Installing and configuring the DNS server, step-by-step installation. 1. Add the DNS server, add the DNS service. Open control panel, add remove programs, add remove Windows components, select networking services and click details. Check domain name system DNS and complete the installation. 2. Configure DNS, open DNS management console, DNS mgmt.msc. Create a new forward lookup zone matching the AD domain name corp.contoso.com. Choose zone type primary and store it in a standard file for standalone or Active Directory if prompted to a domain controller. Enable dynamic updates if using AD reverse lookup zone. Create a reverse lookup for your subnet 192.168.1.x becomes 1.168.192 in ADDR ARPA. Enable IP to name resolution, verify records, check the SRV record under MS, DCS, sites, TCP, and UDP. 7.5 DNS zone types. 1. Primary zone, the authoritative writable version of a DNS zone. 2. Secondary zone, a read-only copy pulled from another server, useful for redundancy. 3. Active Directory integrated zone, stored in the AD database and replicated automatically with the domain feature AD integrated standard primary replication method, AD replication zone transfers, security via ACLs, yes, no, supports multi-master update, yes, no. 7.6 Dynamic DDNS. Windows 2000 introduced dynamic DNS, allowing clients and domain controllers to automatically register and update their own DNS records. How DDNS works. When a computer joins the domain or boots, it sends a request to register its A and PTR records. Domain controllers also register SRV records. Secure dynamic updates available in AD integrated zones ensures only authenticated devices can update DNS. 7.7 Managing DNS record types of common records. Record type purpose A maps a host name to an IPv4 address. Record type purpose PTR maps an IP address to a host name. C name alias for another name. SRV service locator for AD functions. NS identifies authoritative name servers. You can manage records through the DNS management console or programmably via dnscmd.exe. DNS troubleshooting tool. Use NSLOOKUP, query DNS records manually. ipconfig, registering DNS DC diag, test DNS forces DNS registration, test domain controller DNS health. NetDiag runs detailed network tests. Event viewer.msc, view logs for DNS related errors. Missing SRV records. AD services won't be discoverable. Improper zone name must match AD domain name exactly. Dynamic updates disabled. Blocks auto registration of domain members. DNS server misconfigured on client. Clients must use internal DNS, not ISP DNS. 7.9 Best practices for DNS in Windows 2000. Always configure clients to use internal DNS servers. Use Active Directory integrated zones for fault tolerance and secure updates. Enable aging and scavenging to clean up stale records. Configure reverse lookup zones for troubleshooting and logging. Deploy secondary DNS servers for high availability. Periodically use DC diag and NetDiag to validate DNS and AD help. Scenario: deploying DNS in a small enterprise AD environment. Domain name corp.example.com. Servers 2. Windows 2000 DCs with domain controller. Clients 156. Mixed Windows 2000 XP clients. Steps taken. Installed DNS on both clients. Create AD integrated forward and reverse zones. Verify dynamic update functionality via client registration. Use DC diag. Test DNS to validate DC help. Applied group policies to prevent clients from overwriting DNS summary. In Windows 2000 Server, DNS is no longer optional. It is an essential infrastructure component. Proper configuration and maintenance of DNS services ensure that Active Directory, domain logons, and service discovery work reliably. Understanding the integration between DNS and AD is the key to troubleshooting and managing enterprise networks effectively. In the next chapter, we'll explore user and group management, including strategies for organizing users, applying permissions, and managing security in Active Directory environments. So I'm going to leave it here today for this video. Thanks for taking the time to listen, and have a good evening.